This video is about compound interest. Simple interest is calculated solely on the principal or original amount of a loan. Compound interest, which is what we'll be working with here, is calculated on the principal amount and the accumulated interest of the previous periods. The more often your interest is compounded, the more you earn over the lifetime of the account. Formulas for compound interest include compounded n times per year. We have A equals P parentheses 1 plus R over N close parentheses to the NT, where A is the amount, capital P is the principal, or the original amount of your loan. R is your rate, your interest rate. N is the number of times that your loan is compounded per year. And T is the number of years. If your loan is compounded continuously, then the formula is A equals PE to the RT, where E is Euler's number. Let's look at a few examples. I'll leave the formulas up there. So suppose Logan places $6,500 in an account that pays 2% interest compounded each year. So it's compounded yearly. Assume that no withdrawals are made from the account. Find the amount in the account at the end of 2 years. Do not round. Okay, so let's go ahead and identify the different pieces of our function. So that P, the principal amount, is the amount that he invested. So P is going to be 6,500. The interest rate is 2%, and I want to write that as a decimal. So I'll write that as R equals 0.02. N is the number of times that it's compounded each year. So N is 1 in this case because it says compounded each year. And then T is the number of years. So T is 2 in this case. So the amount after 2 years is going to be 6,500 parentheses 1 plus 0.02. N is 1, and I don't have to write dividing by 1 because if I divided by 1, I would just get the 0.02. And again, N is 1, so when I do an exponent of 1 times 2, I'm just going to get a 2 up here. So now I have to put that into the calculator. Let me pull up my Desmos calculator real quick. So I'll have 6,500 parentheses 1.02, close the parentheses, raised to the second power. So the amount of my loan will be 6,000, or actually in the account, it's not a loan, it's his bank account. So $6,762.60. And this is dollars, so 6,762.60. So that would be after 2 years if he did no more no more investments and no more withdrawals in that account. Let's look at some more examples. I'll continue to use these formulas for compound interest. Fayez deposited $4,000 into an account with 2.1% interest compounded semi-annually. Semi-annually means twice per year. So that is twice per year. So that tells me my N. So that will be N equals 2. The interest rate will give me my R. So I'll have R equals 0.021 because I want to change that to a decimal. The initial amount was 4,000. So that will give me the P. P is 4,000. And assuming that no withdrawals are made, how much will he have in the account after 3 years? So that would give me my T. So T is 3. Do not round any intermediate computations. Round your final answer to the nearest cent. So I'll have the amount after 3 years is going to equal 4,000 parentheses 1 plus R, so 1 plus 0.021 divided by N, which is 2. So 0.021 over 2 added to 1. And then in the exponent, we'll have N times T. So this will be 2 times 3. N is 2, T is 3. So that will be the 6th power. So when I'm entering that in my calculator, I would go ahead and put in 4,000 parentheses 1 plus the fraction 0.021 over 2, all raised to the 6th power. So I'll put that in exactly as I see it, 4,000 parentheses 1 plus, and then 0.021 divided by 2, exponent of 6, and that would give me my final amount, $4,258.71. So again, that was $4,258.71. So it's all about identifying the different parts of your formula, P, R, N, and T. All right, another example. Cassandra borrowed $8,000 at a rate of 7.5% compounded monthly. Assuming she makes no payments, how much will she owe after 3 years? Do not round any intermediate computations. Round your final answer to the nearest cent. So remember the formula is A equals P parentheses 1 plus R over N close parentheses to the NT. So I'm going to have my principal amount of 8,000 parentheses 1 plus my rate is 7.5%, which would be 0.075. N is the number of times per year. So if it's compounded monthly, that would give me N equals 12. So I'll put 0.075 over 12. And then in the exponent, I'll have 12 times t, so 12 times 3. And so in the calculator, I want to put that in as 8,000 parentheses 1 plus the fraction 0.075 over 12 to the 36. $8,000 parentheses 1 plus 0.075 divided by 12, close the parentheses, raised to the 36th power, $10,011.57. So $10,011.57. So on this loan, she would end up paying an extra $2,011 basically, just because of the interest. All right, let's do one last example with continuous compounding. And here are my formulas. Money Savers Bank offers a savings account that earns 8% interest compounded continuously. So automatically that puts me in this situation, A equals PE to the RT. If Aheen deposits $1,400, how much will she have in the account after 2 years? So this is my principal, 1,400. T is 2. So I'll have A is what I meant to say. All right, so I have A equals P, which is 1,400. E, the interest rate is 0.08. 8% would be 0.08 times 2. So when I put that in, I would go ahead and put 1,400 E to the 0.16. I would go ahead and multiply and get the exponent before putting it into my calculator. So we'll go ahead and do 1,400. To get to E, you go to function and select e to the x, back to the main calculator and put in your exponent. And that would give you the amount, $1,642.92. All right, so now you've seen examples where your account or loan gets compounded n times per year, and you've seen an example where your account or loan is compounded continuously.